In today's video, we're going to talk about using the first derivative to find out where a function is increasing and decreasing. So in this first slide, if you notice that I have written here that the first derivative, when it is greater than 0, we can then state that it's increasing. If the first derivative is less than 0, we will then state that it's decreasing. So if you look, the slope of the tangent lines is positive and you can see how it's increasing. Then you have a critical point where the slope of the tangent line is 0, and then you have the slope of the tangent lines are negative and you can see that it's decreasing. So these two things do hold true. The first derivative test is just simply a way that we're going to check to see if something's a relative max or a min, and we'll do this using intervals. If we find out that f prime is positive or increasing on the left-hand side, then changes to decreasing on the right-hand side, it has to be a max, as you can see in the picture. If f prime changes from decreasing to then increasing, you will then know that it's a minimum. In this graph, all we're going to do is simply state what intervals are increasing and decreasing. So the first interval I want to talk about is right here. You can see that it's increasing all the way to 0. So from negative infinity to 0, it's increasing. Then at 0 to 1, it decreases. And then from 1 to infinity, it increases again. Don't overcomplicate these types of problems.
The next problem we're going to look at is one where they don't give me a picture. Now, of course, I could use my graphing calculator to come up with a picture, but we're not going to do that. We're going to compute the first derivative, and we're going to test those values. So when I take the first derivative, actually, let's go ahead and rewrite this first. Let's say y equals x plus 4x to the negative 1. Now let's go ahead and take the derivative. I get 1 plus negative 4x to the negative second. It's imperative that I change it out of this form. So I'm going to say it's 1 plus, this would be negative 4 over x squared. It's going to be much easier to solve for my y prime. I want to know where those critical numbers are, so I'm going to set it equal to 0. And we're going to test those values. So I've got, when I move over my 4 over x squared to the other side, 4 over x squared equals 1. I'm going to come up here to finish this. I will go ahead and cross multiply. So when I cross multiply, I get 4 equals x squared, and then I'll square root both sides, which gives me plus or minus 2. Now, I'm going to also take note that not only do I have critical numbers at 2 and negative 2, I also have a critical number because at x equals 0, the y prime is undefined or does not exist. So I also need to include 0 as a value of testing whether it's positive or negative. Now, when I go to test the values, I'm going to test whether or not their slopes of the tangent lines of the curve are positive or negative. So I'm just going to pick a value between 0 and 1 first. I could start down here on the end, but I'm not going to. So between 0 and 1, what is the slope of the tangent line? I don't actually have to have the exact value. I will actually continue this on the next video. I'm getting ready to test the intervals, and so that's what I'm going to do right now. When I'm testing the intervals, I am going to just try numbers in between here, and I'm going to put them into the first derivative because I'm curious what's going on with the first derivative. Is it positive or negative? So I don't actually have to come up with the exact value. I just need to know if it's positive or negative. So if I test 3, that would be something greater than 2. So if I put 3 in here, I notice I get negative 4/9. So at 3, it would be 1 plus negative 4/9. That would be a positive value. So I'm going to put a plus sign above here, meaning the slopes of the tangent lines at the curve are all positive in this interval. If I try 1, put 1 in here, I get 1 plus negative 4 over 1. That would be a negative number. So the numbers between 0 and 2 are negative. All the slopes of the tangent lines are negative, meaning it would be decreasing. If I try negative 1, I have 1 plus negative 4 over negative 1 squared is 1. So I still have a negative value here. And then if I try negative 3, I have 1 plus 4 over negative 9, which would be another positive value. So that means the slope of the tangent lines are all increasing here. So what I'm able to do is identify those open intervals on which it's increasing. It's increasing from negative infinity to negative 2. Okay, because negative infinity is over here, up to negative 2. And it's also increasing from 2 to infinity. So those are my increasing intervals. It's decreasing from negative 2 to 0 and from 0 to 2. Let's try another one. On this one, I think it's much easier. We're going to find the critical numbers, and then we're going to find whether the function is increasing or decreasing. And on top of that, we're going to locate whether we have relative maxes or mins. What I was getting ready to say is I think it's easier on this one to actually not use product rule and actually just go ahead and multiply what is x plus 2 times x plus 2. Multiply this out. So I'm going to go ahead and do that. I get x squared plus 4x plus 4, and then I have x minus 1. When I multiply these together, I end up getting x cubed plus 3x squared minus 4. Now you may need to multiply those all out and to come up with this value, but to save a little time, I'm going to go ahead and just tell you what that equals. F prime of x then ends up being 3x squared plus 6x. Now we're looking for those critical numbers, so we're going to set this equal to 0. There are no values we need to test where the derivative does not exist because there's no fractions. We can factor out of 3x, and we're left with x plus 2. So that means there's two values I need to try right now, when x is 0 and when x is negative 2. So what I'm going to do is I'm going to create that number line that I did in the last problem. I'm going to label it this time f prime. I'm testing f prime. So I'm going to go back here and I'm going to circle that. I want to test the intervals. Here's 0, here's negative 2. We know that the slopes of the tangent lines are 0 at those. What's going on before it hits negative 2? Is it positive or is it negative? So if I try negative 3 and I put negative 3 in for there, I'll have 3 times negative 3 squared plus 6 times negative 3. Well, that is 27 plus negative 18. That's a positive value, so I know that all the slopes of the tangent line of the curve are positive here. Then if I try negative 1, I'd have 3 times negative 1 squared plus 6 times negative 1. Well, that would give me 3 plus negative 6. This is a negative value, so all the values are decreasing. All slopes of the tangent lines are negative. And then the last one, if I put 1 in there, I'm going to get positive, so I know it's increasing there. So I'll go ahead and first just write down that my intervals of increase are from negative infinity to negative 2 and from 0 to infinity, so those are increasing. And then my interval of decrease is negative 2 to 0. Now I'm also supposed to find those relative max or mins. What I like to do is I like to just go ahead and pretend that this is partially a function here, and I like to draw in, okay, well, it's increasing, then it's decreasing, then it's increasing. So I know here's max and here is a min. So I'll go ahead and write that in here, that negative 2 comma something is a max, and 0 comma something else is a minimum. We go back to find our y values from the original. This means y. I'll just go ahead and tell you what you get when you plug those in. You get 0 and you get negative 4. Okay, in this problem we're going to be doing the same things. I'm finding the critical numbers and finding the intervals that increase and decrease and the relative extrema. I'm going to go ahead and rewrite this first. I do not want to use quotient rule on a problem like this. It's much easier to take the derivative if we just go ahead and rewrite it. I will then reduce this to be 1 over x plus 3 over x squared. So then I can rewrite this as x to the negative first plus 3x to the negative second. Taking the derivative gives me negative x to the negative second plus negative 6x to the negative third. Now it's going to be hard to set that equal to 0 unless I go ahead and rewrite it. We have 6 over x cubed. Again, this is hard to set equal to 0 until I make a common denominator. So I'll start to do that, and my common denominator is going to be x cubed. So I'm going to leave this one alone, x cubed, and I'll have the 6 still on top. This one I need to multiply the top by x, so I have a negative x. I'll come up here to finish that. My first derivative ends up saying negative x minus 6 over x cubed. Now I'm finally ready to set this equal to 0. I'll take note that on the bottom, I need to test x equals 0 because it's going to be discontinuous. It's discontinuous on the function. And I also need to go ahead and figure out what the top gives me and where it's equal to 0. So if I do that, I get at -6, there is a critical point or critical number. We need to test those on an interval, so I'm going to put 0 and -6 on my interval, and I'm again going to be testing the first derivative. So when I go ahead and plug in my -7, because I'm going to test the -7 here, I will end up getting a negative value for my slope of the tangent line to the curve. When I try, maybe I'll try -1, I'd have a positive 1 minus 6, which is a -5, over a -1, so that ends up giving me a positive interval. And then the last one here, from 1, when I put 1 in there, I ended up with -7 over 1, which is a negative interval, meaning it's decreasing. So the intervals of decrease are from from negative infinity to -6, and from 0 to infinity. So those are decreasing. And then our interval of increase is from -6 to 0. So this is where it's increasing. The last thing I'm going to do is mark my relative max or mins. So in this one I have decreasing, then increasing, then decreasing. So I have relative max at 0 and a relative min at -6. So I'll squeeze that in here. My max is at 0, comma, something, relative max. My relative min is at -6, comma, something. So where am I going to plug this in? We'll have to plug it back in for a y value. So when I plug 0 up here, well, that's not going to be a max or a min because it doesn't exist. So there is no max. Remember, it was discontinuous there. So that's the reason why. Then I'll plug in -6. -6 plus 3 is -3. -6 squared is 36. That gives me a -1/12. So I'm going to really have a relative min on this problem.